Imagine you're a worker at a construction site for a home. The concrete foundation's been set and several workers are in the process of framing the walls. You pick up a hammer and are about to join in when the site supervisor taps you on the shoulder and says, "Aren't you forgetting something?" he asks. You look at the supervisor and he points to your head. You realize you forgot to put on your hard hat. A hard hat is an example of personal protective equipment, also known as PPE. PPE is a way to control workplace hazards when other controls are not sufficient. In the example I just provided, the hard hat is a means of protecting your head from injuries on the worksite that could occur from a falling object or from bumping your head against a fixed beam or a scaffold brace. Standards by the Occupational Safety and Health Administration, or OSHA, mandate that employers have to protect employees from workplace hazards that can cause injury, such as machinery, hazard work substances, or dangerous work procedures. Employers can do this by using controls to eliminate and reduce hazards. PPE is one type of control that should be used when other controls have not eliminated the hazards. In this course, we're going to take a deeper look at using PPE controls. By the end of this course, you'll be able to describe the two primary means of protecting employees from workplace hazards before considering PPE. Explain what should be included in PPE training, list PPE that may be used for protection, and identify hazards that are reduced or eliminated by using the appropriate PPE for eye, face, head, hearing, foot, hand, and body protection. Before considering PPE, there are two primary means of protecting employees from workplace hazards: engineering controls and administrative and work practice controls. If both of these controls are used and hazards still exist, then PPE controls can be put in place. Let's take a closer look at each of these three types of controls in more detail. Engineering controls are the first type of control that must be used. These are all about the design of the work environment and the job itself. If the work environment or job can be changed physically to prevent employee exposure to the potential hazard, then the hazard can be eliminated with the engineering control. Examples of engineering controls include initial design specifications, less harmful material substitutions, change processes, enclosed processes, isolate processes, and ventilation. The other primary set of controls that should be used are administrative and work practice controls. Administrative and work practice controls include the organization's general procedures, workplace procedures, and other operation-specific rules. If employees can eliminate their exposure to the potential hazard by changing the way they do their jobs, then the hazard can be removed with an administrative and work practice control. Examples of administrative and work practice controls include the use of wet methods to suppress dust, personal hygiene, housekeeping, employee rotation, time, day, or work hour changes, and maintenance. If feasible, engineering and administrative and work practice controls have been used and the hazards have not yet been eliminated, PPE controls can then be used. PPE is always the last level of control used. Let's look at some examples of PPE. Hard hats are for the head for protection. Face shields are worn to protect the face. Safety glasses or goggles are used to protect the eyes. Earplugs or earmuffs are worn for hearing protection. Vests protect the body or increase visibility. Gloves protect hands and arms. Safety shoes are worn to protect feet. When PPE is warranted, the employer must provide at no cost to the employee. A PPE program must be put in place if employees are still exposed to potential hazards after all feasible engineering and administrative and workplace practice controls are in place. A PPE program sets procedures for selecting, providing, and using PPE as part of an employer's routine operation. To establish a PPE program, the employer must follow a few steps. First, the workplace must be assessed to determine if hazards are present or likely to be present. If there are hazards that necessitate the use of PPE, the proper PPE must be selected and made available to all employees. Employers must also provide training to every employee required to use PPE. This training must cover several areas. Each employee must learn when and what type of PPE is necessary, how to properly wear, adjust, and remove PPE, the limitations of PPE, and finally, the proper care, maintenance, useful life, and disposal of the PPE. Upon completion of the training, employees must demonstrate an understanding of what they've learned. This includes being able to demonstrate how to properly use the PPE. If an employee can't demonstrate the required skills and understanding, the employee must take the training again. Employees receive certificates of completion upon successfully demonstrating the required skills. Consider this. A milling operation produces large quantities of metal chips that fly all over the surrounding work areas. Recognizing that flying metal chips are a potential hazard to employees, the machine shop owner will implement three methods of protection for workers. First, engineering and administrative and work practice controls will be put in place. Which of the following options should be the third and final level of the protection the shop owner will put in place? Is it A, enclose the milling operation to contain the metal chips from flying into the surrounding areas? B, provide employees with safety goggles? C, operate the machine only at certain times of the day when adjacent operations have stopped? Or D, provide the employees with earplugs? The correct answer is B, provide employees with safety goggles. This is a PPE control. PPE is always the last level of control to use. The primary means of protecting employees should be through engineering controls and administrative and work practice controls. These should be in place before the PPE control. The engineering control is a selection A, enclose the milling operation to contain the metal chips and prevent them from flying into the surrounding areas. This control physically changes the work environment to prevent employee exposure to the hazard. The administrative and work practice control is selection C. Operate the machine only at certain times of the day when adjacent operations have stopped. This is an administrative and work practice control because it changes the way the employees do their jobs by removing them from the hazards. Selection D. Provide the employees with earplugs is a PPE control, however, it does not protect against the hazard of the flying metal chips. Now we'll explore head protection. Head injuries can be caused by falling objects or by contact with exposed electrical conductors. Other head injuries occur by bumping your head against fixed objects, such as exposed pipes or beams. In any of these cases, hard hats must be worn. Hard hats are divided into classes and vary depending on the type of hazard they protect against. Class G hard hats are for use during general services such as mining, building, construction, shipbuilding, lumbering, and manufacturing. Class G hard hats provide good impact protection, but they have limited voltage protection. Use Class E hard hats during electrical work. These hats protect against falling objects and high voltage shocks and burns. Finally, there are Class C hard hats. They're designed for comfort but offer limited protection. These hard hats can help protect from bumps against fixed objects, but they can't protect against falling objects or electrical shock. No matter the class, all hard hats must adhere to certain requirements. First, they must have a hard outer shell. They also have to have a shock-absorbing liner that's ventilated. To accomplish this, the liner should have a headband with straps that suspend the shell from 1 to 1 1/4 inches away from the user's head. Look inside the hard hat to find a label with the manufacturer's name. The American National Standards Institute, or ANSI standard it meets, and its class. Employees need to be trained in the proper use of these hard hats. Hard hats must be used and worn and designed in order to comply with ANSI standards. Employees need to follow the manufacturer's instructions regarding wearing a hard hat backwards. Employees must also be trained in the proper maintenance of hard hats. Hard hats need to be inspected daily to ensure that they continue to provide sufficient protection. If the suspension system shows deterioration or no longer holds the shell away from the employee's head, the hard hat must be removed from service. The brim or shell must not be cracked, perforated, deformed, or show signs of exposure of heat, chemicals, or ultraviolet light. Be aware that paints, paint thinners, and some cleaning agents can weaken the shell of the hard hat and may eliminate electrical resistance. Do not use paint on hard hats. You should also limit the use of stickers, which can hide the signs of deterioration on the shell. What if engineering and administrative and work practice controls have been put in place at the worksite, but there's still a chance for eye or facial injuries that can occur? In this case, employers must provide eye or facial protection for employees. Employees must wear this protection whenever they're exposed to this type of potential injury at the worksite. What can cause eye or facial injuries? Sometimes these types of injuries occur from dust or other flying particles, such as metal shavings or sawdust. Molten metal can also splash toward the face. In work sites with chemicals, acids, and other caustic liquids, chemicals can be splashed. Some workplaces might cause risk for blood or other potentially infectious body fluids that may splash, spray, or splatter. There can also be risk of injury due to intense light, such as that created by welding and lasers. If any of these pose a risk, eye or face protection is required to be worn. Let's take a look at a few of these examples and types of PPE. One type of protection is safety spectacles. Safety spectacles protect moderate impact around the eyes from particles produced by jobs such as carpentry, woodworking, grinding, and scaling. Safety spectacles have metal or plastic frames. Most operations require the spectacles to have side shields. Another type of protection is goggles. Goggles protect eyes, eye sockets, and the facial area surrounding the eyes from impact, dust, and splashes. Some goggles can fit over contacts and glasses. Check with your supervisor, though, regarding those types of goggles. If employees are working with or near lasers, special laser safety goggles must be worn. These safety goggles protect eyes from intense concentrations of light produced by lasers. Welding shields can protect eyes from burns by infrared or intense radiant light. Welding shields also protect the eyes and face from flying sparks, metal spatter, and slag chips produced during welding, brazing, soldering, and cutting. Finally, face shields protect the face from nuisance dusts and potential splashes or sprays of hazardous liquids. Face shields do not protect employees from impact hazards. Safety glasses must be worn under the face shield in those instances. Each year, 30 million people are exposed to hazardous noise on the job. This type of noise can cause permanent hearing loss that neither surgery nor hearing aids can repair. What exactly is hazardous noise and how can you avoid damage from it? Sound is vibrations detected by the human ear. When sound is unwanted, it's called noise. When noise occurs at high levels or for a duration of time, it can be hazardous and harmful to workers. The higher the level of the noise, the more potentially harmful it is to your hearing. The need for protection is dependent upon several factors. How loud is the noise? How long is an employee exposed to the noise? Do employees move between separate work areas with different noise levels? Is the noise from one source or multiple sources? All of these factors must be taken into consideration. Generally, the louder the noise, the shorter the exposure time before hearing protection is needed. This chart shows acceptable noise exposures. If employees are exposed to noise levels outside this chart, then engineering and work practice controls must be in place to reduce the exposure. In the case that these controls do not sufficiently reduce noise exposure, then hearing protection must be provided to the employees. Hearing PPE can come in the form of earmuffs, formable earplugs, and canal caps. Each has their own noise reduction rating that will reduce the noise exposure by a certain amount. Sometimes hazard assessments can identify potential sources of bodily injury. These could be intense heat, splashes of hot metals or other hot liquids, impact from tools, machinery, and materials, cuts, hazardous chemicals, contact with potentially infectious materials such as blood, and radiation. When there is still a chance for injury after all possible engineering and work practice controls are in place, body PPE must be provided. Body PPE comes in the form of protective clothing. Depending on the hazard, the correct form of protective clothing must be worn. These include cooling vests, sleeves, an apron, coveralls, or full body suits. Body protection also comes in a variety of materials, each meant to protect against a particular hazard. Paper-like fiber is used in disposable suits to protect against dust and splashes. Clothing made of treated wool and cotton adapts well to changing temperatures, is fire-resistant, and protects against dust, abrasions, and rough or irritating surfaces. Duck fabrics protect against cuts and bruises when handling heavy, sharp, or rough materials. Leather is a good material to protect against dry heat and flames. Rubber, rubberized fabrics, neoprene, and plastics protect against chemicals and physical hazards. When chemical or physical hazards are present, check with the clothing manufacturer to ensure that the material will provide protection in your situation. Certain environments and jobs put employees at risk of hand injuries. Hand injuries can be burns, bruises, abrasions, cuts, punctures, fractures, amputations, and chemical exposures. If there's a risk of a hand injury, hand protection must be provided. Hand protection usually comes in the form of gloves. The nature of the hazard and the task performed will determine the type of glove. As we've discussed, there are a variety of potential hand injuries, and selecting the appropriate pair can be complex, especially in comparison to choosing other protective equipment. One must take care to choose gloves designed for the particular circumstances of your workplace. Glove manufacturers can also provide valuable assistance. Let's talk about some of the different types of gloves. Norfoil gloves are a laminate material. These gloves resist permeation and breakthrough by several different types of toxic or hazardous chemicals. Butyl gloves provide the highest permeation resistance to gas or water vapors. These gloves are frequently used to protect against keatones such as acetone and esters like ethyl acetate. Biton gloves are highly resistant to permeation by chlorinated and aromatic solvents. There are also nitrile gloves. These provide protection against a wide variety of solvents, harsh chemicals, fats, and petroleum products. Nitrile gloves also provide excellent resistance to cuts, snags, punctures, and abrasions. Kevlar gloves can be worn to protect against cuts, slashes, and abrasions. Finally, stainless steel mesh gloves protect against cuts and lacerations. Sometimes a work site or job can introduce hazards to the feet. Heavy objects such as barrels or tools that might roll onto or fall onto the feet can cause foot injuries. Sharp objects like nails or spikes could pierce the soles or uppers of the ordinary shoe. In some cases, molten metals might splash onto feet. More commonly, foot injuries occur due to hot, wet, or slippery surfaces. Foot protection, PPE, must be provided in each instance where other controls have not eliminated the risk for injury. Safety footwear must meet minimum compression and impact performance standards and testing requirements. Safety shoes have impact-resistant toes and heat-resistant soles. These protect against hot surfaces common in roofing, paving, and hot metal industries. Sometimes, safety shoes will have metal insoles to protect against puncture wounds. In other cases, metatarsal guards can be worn. These guards are either already a part of the shoe, or they can be an additional piece strapped to the outside of the shoe to protect the instep, toes, and top of the feet from impact and compression. Sometimes, an electrically conductive shoe is necessary. Employees working in explosive or hazardous locations, such as an explosives manufacturing facility or on an agricultural grain elevator, must wear these. Conductive shoes act as a grounding agent and therefore protect the employee against the building of static electricity, which could produce a spark and cause an explosion or fire. Employees must be trained on this type of shoe before wearing them. It's not a general purpose shoe and must be removed when that task that's required for their use is complete. Employees must not use foot powder during their use because it insulates and retards the conductive ability of the shoe. Employees must also be sure not to wear socks made of silk, wool, or nylon, as these materials produce static electricity as well. Employees exposed to electrical hazards must never wear conductive shoes. There are also instances where non-conductive shoes must be worn to protect employees from electrical hazards. In these cases, electrical hazard safety toe shoes are worn to prevent feet from completing electrical circuits with the ground. They can protect against open circuits of up to 600 volts in dry condition. Use these shoes in conjunction with other insulating equipment and precautions that reduce or eliminate a path for hazardous electrical energy. Never wear non-conductive footwear when in explosive or hazardous locations where conductive shoes must be worn instead. Consider this scenario. A worker at a plant has the potential of being exposed to hazardous chemicals. In addition to engineering and administrative and work safety controls, what combination of PPE would best protect the worker from this hazard? Is it A, Class G hard hat, conductive shoes, and Kevlar gloves? B, stainless steel mesh gloves and treated wool and cotton coveralls? C, face shield, nitrile gloves, rubber coveralls, and boots? Or D, Norfoil gloves, face shield, duck fabric coveralls, and boots? The correct answer is C, face shield, nitrile gloves, rubber coveralls, and boots. These items will protect the worker from hazardous chemical exposure. Hard hats shield against falling or fixed objects and electrical conductors, and conductive shoes prevent the buildup of static electricity. Both Kevlar and stainless steel mesh gloves protect against cuts, but not chemicals. Finally, treated wool and cotton protect against dust, abrasions, and rough or irritating surfaces, and duct fabric protects against cuts and bruises when handling heavy, sharp, or rough materials. In this course, we've looked at the requirements for personal protective equipment. Contrary to popular opinion, PPE must be the last control to consider. Engineering and administrative and work practice controls should be the primary means of protecting employees. If PPE is necessary, then a PPE program along with employee training must be put in place. The training must teach employees when PPE is necessary and what type of PPE is appropriate. The training must educate employees on how to properly put on, take off, adjust, and wear PPE, as well as their limitations, proper care, maintenance, useful life, and disposal. We also covered different types of PPE to protect the eyes, face, heads, hearing, feet, hands, and body. We identified hazards such as flying particles, hot surfaces, and chemicals, and how to reduce their risk by using the appropriate PPE.
This training will provide basic information on respirators and respiratory protection to workers and employers, including what respirators are, how respirators function, and what is needed for a respirator to provide protection. A respirator is a device that is intended to protect employees from inhaling dangerous substances, such as chemicals and infectious particulates. Respirators are among the most important parts of protective equipment for working in hazardous environments. Choosing the right respirator requires an assessment of the workplace functions, processes, and environments that may create a respiratory hazard. There are many different types of respirators that will be described in this module. Identifying the hazards and airborne concentrations must be determined before choosing a respirator. This assessment should be done by experienced safety personnel or an industrial hygienist. Respirators work three ways: filtering particles from the air, chemically purifying the air, or supplying clean air from an outside source. Particulate respirators, those that filter particles from the air as the user breathes, are the simplest, least expensive, and least protective of the respirator types available. These respirators only protect against dust-like particles. They are not designed to protect against chemicals, gases, or vapors. These respirators are intended only for low hazard levels. The commonly known N95 filtering facepiece respirator or dust mask is one type of particulate respirator, often used in hospitals to protect against infectious particulates. Particulate respirators filter out dusts, fumes, and mists. Dusts you likely know about, but what about fumes and mists? Fumes are actually solid particles suspended in the air, and mists are actually liquid particles suspended in the air. Particulate respirators are usually disposable dust masks or respirators with disposable filters. These filters must be replaced when they become discolored, damaged, or clogged. A particulate respirator, like its cousin, the chemical cartridge respirator, is often called an air purifying respirator because it purifies the air by removing solid particles from the air as you breathe. Chemical cartridge gas mask respirators, also known as air purifying respirator, are respirators that filter or clean chemical gases and vapors out of the air as you breathe. All air purifying respirators include a facepiece or mask and a filtering device for chemicals. This filtering device will be a cartridge or canister, whereas a particulate respirator will have a filtration cartridge or pad of some kind. Straps secure the facepiece to the head. The chemical cartridge respirator may also have a filter to remove particles as well as the filter to remove gases and/or vapors. Chemical cartridge gas mask respirators are effective only if used with the correct cartridge and/or filter that will filter the chemical or biological substance sufficiently to protect the wearer. Selecting the proper filter and cartridge can be a complicated process. There are cartridges that are designed to protect against more than one hazard. There is one thing that you must also remember: there is no one cartridge or filter that protects against all substances. So you can see why it is important that we know what hazards you will face in order to be certain you are choosing the right filters and/or cartridges. Chemical cartridges and canisters are color-coded to help you select the right one. These These may require more than one cartridge to protect against multiple hazards. The powered air purifying respirator, or PAPR, is similar to the air purifying respirators we just discussed. The difference is that with the chemical cartridge and particulate air purifying respirators, your breathing in and out makes the filtering process work. In the case of the powered air purifying respirators, a fan is used to draw air through the filter to the user. As you can imagine, these PAPR respirators are easier to breathe through, but there is a drawback. They need a fully charged battery to work properly. Most PAPRs use the same type of filters, cartridges as the other air purifying respirators. As with the other air purifying respirators, with a PAPR, it is imperative that we know what the hazard is and how much of it is in the air in order to select the proper filters and cartridges. Self-contained breathing apparatus, called SCBA for short, are respirators that provide clean air from a portable air tank when the air around you is simply too dangerous to breathe. Firemen routinely use this type of respirator. So do underwater divers. Only the underwater type of SCBA is much different than the one used on land. However, SCBAs are heavy, 30 pounds or more, and they require special training on how to use and maintain them. Also, the air tanks typically last an hour or less, depending upon their rating and your breathing rate, how hard you are breathing. Most of these respirators are available in either half mask or full face pieces. The exception is the dust mask. It only comes in the half face model. Filtering face piece or dust masks are generally made from a cloth or paper-like filter material. Chemical cartridge gas mask respirators can be made from a variety of materials, each specifically designed and formulated to remove the vapor of gas hazard that it is supposed to. We'll talk more about these color codes in a minute. The most popular face piece materials are silicone, neoprene, and rubber. In general, rubber and neoprene are rigid but durable materials. Silicone is usually preferred for its comfort, flexibility, and ease in cleaning, but it is usually less durable than the rubber or neoprene materials. Depending on the brand, full-face respirators are available with strap harnesses or ratchet suspensions. The harness type can be worn under a hard hat, but ratchet suspensions are generally easier to adjust, making donning and doffing easier. Various features are available to help you customize respirators to suit the respirator wearer and to more appropriately protect the wearer from the specific hazards they may encounter. For example, nose cups reduce lens fogging with full face piece respirators. Lens covers protect the lens from paint and minor chemical splashes and scratches. Spectacle kits may be needed when using prescription-corrected lenses, and each brand has its own style. But in general, the frame mounts into full-face masks, and the prescription lenses made by the user's optometrist fit into the frame. This allows the wearer to maintain a proper fit and still wear prescription lenses. There are 9 classes of particulate filters that are broken down into 3 series, N, R, and P. Each series, N, R, and P, is available at 3 efficiency levels, 95%, 99%, and 99.97%. The N series filter is used in environments free of oil mists. The R series filters can be exposed to oil mists, but should only be worn for one shift. The P filter can be exposed to oil mists for longer than one work shift. Cartridges are assigned a color designating the type of contaminant they filter. Acid gases are white. Hydrocyanic acid gas is white with a half-inch green stripe completely surrounding the cartridge or canister near the bottom. Chlorine gas is white with a half-inch yellow stripe completely surrounding the cartridge or canister near the bottom. Organic vapors are black. Acid gas is green. Acid gases and ammonia gases are green with a half-inch white stripe completely surrounding the cartridge or canister near the bottom. Carbon monoxide is blue. Acid gases and organic vapors are yellow. Hydrocyanic acid gas and chloropicrin vapor are yellow with a half-inch blue stripe completely surrounding the cartridge or canister near the bottom. Acid gases, organic vapors, and ammonia gases are brown. Radioactive materials except tritium and noble gases are purple or magenta. Cartridges and filters expire. If the filter cartridges have expired, have been opened to the air, or are damaged, then the user may not be protected. Cartridges that contain charcoal or other chemicals for filtering the air should be kept in airtight packages until use. If cartridges are open or not packaged in airtight packaging, they should not be used. Even cartridges in original packaging have expiration dates that must be checked before purchase and use. As a general rule, the more chemical or biological hazard in the air, the shorter the time your filter will last. There is no absolute time limit, and it will vary by each respirator model's capacities and the concentration of the hazard. Nevertheless, cartridges do have a limited service life, and they must be changed, and periodically during use, your safety professional will specify service life of the cartridge, depending on the contaminant and the level of the contaminant in the work area. Air purifying respirators do not provide oxygen. If used in an environment with low oxygen levels, such as in a fire or confined space, the wearer is in danger of asphyxiation. In the event of a fire, most respirators will not protect the wearer. It is important to read the manufacturer's information if the main concern is to be able to escape from a smoke-filled building. Smoke particles can rapidly clog respirator filters, and filters with special chemicals are needed to protect against carbon monoxide and other gases that may occur in a fire. Not all respirators, not even escape respirators, protect against these hazards. Some components, including hoods and facepieces of many of the respirators, may melt if exposed to the heat of a fire. Each category of respirator comes in several varieties, each with its own set of cautions, limitations, and restricted use. Tight-fitting respirators require fit testing to ensure an adequate fit to the face. A tight-fitting respirator cannot be used with facial hair. Certain escape respirators use a nose clip and mouthpiece that is clenched between your teeth, similar to a snorkel. Some respirators keep the user from talking, while others designed with speaking diaphragms or electronic communication devices. Gas masks and respirators reduce the exposure to the hazard, but if the exposure is such that it goes beyond what the filter or cartridge is capable of handling, either because the amount of toxic gas or particles is more than what the filter is designed to handle, or because the exposure lasts longer than what the filter is designed to handle, the filter or cartridge or combination may not be effective in providing required protection. Also, with work activities and movement of your facial muscles, there may be a small amount of leakage that you cannot easily detect, even if the fit of the respirator and the seal have been tested correctly. If so, and if there is a large amount of a toxic chemical in the outside air, even a small leakage can be dangerous. Anything that prevents the face mask from fitting tightly against the face, such as a beard or long sideburns, may cause leakage. If the respirator requires a tight fit, then the wearer must trim back his beard so that it will not interfere with the face-to-face piece seal. If the respirator is a loose-fitting or hooded positive pressure respirator, then the wearer may wear a beard. Breathing through a respirator is harder than breathing in open air. People with lung diseases such as asthma or emphysema, elderly people, and others who may have trouble breathing probably shouldn't be wearing a respirator. People with claustrophobia may not be able to wear a full face piece or hooded respirator. People with vision problems may have trouble seeing while wearing a mask or hood. There are special masks for people who need glasses. The best way to find out about these personal issues is to conduct a medical evaluation before being assigned to use a respirator. In fact, a medical evaluation needs to take place before a fit test and before training because in both instances, the worker will be wearing a respirator and we must know any medically related issues before wearing a respirator for whatever reason is to be allowed. If the respirator facepiece does not make a tight seal all the way around the face when the wearer inhales, they may breathe contaminated air that leaks around the edges of the face seal. Most respirators come in different sizes and styles because everyone is slightly different, and no one size or design fits all. The only way to tell if a tight-fitting respirator fits you properly and is capable of protecting you is to fit test the respirator, and as stated, the fit test comes second after the medical evaluation. Fit testing can be conducted a number of different ways and must be done by a trained fit tester before workers wear a respirator in a hazardous environment. Every respirator must be checked for proper fit every time it is put on. Why? Again, the answer is to ensure they will provide adequate protection, since that respirator may be the only thing between you and a very bad situation. All users of respirators require training in order to help ensure the respirator is properly used. Some respirators require more training than others. Training follows the medical evaluation and the fit test. Some escape respirators come in a package that must stay sealed until use, so workers need to be trained using a special practice version of the respirator they will be using. It will be necessary to be trained on how to put the respirator on correctly and wear it correctly and to take it off correctly. Training is important in regard to the storage, maintenance, and disposal of the respirator. If a respirator is not used correctly, it is very likely that it will not adequately protect the wearer and may even injure them. Remember, one more important item about respirators. Your respirator may be the only thing between you and a serious overexposure to a chemical or biologic hazard, or perhaps even worse. Respirators must be assigned on an individual basis. If the respirator is assigned to an individual, it should be marked to identify the person to whom the respirator belongs. The marking should not interfere with the performance of the respirator in any way. The OSHA standard covering respirators requires a record to be maintained of the date the respirator was issued. Every respirator contaminated with hazardous chemicals must be cleaned, decontaminated, or disposed of properly. The cleaning process must include removing the filters and cartridges or canisters, washing in a cleaning disinfectant or detergent solution, rinsing, disinfecting, rinsing again, and air drying. Disinfectant tablets or solutions can be obtained from respirator manufacturers. Care should be exercised in the choice of detergents or disinfectants because some can cause damage to the respirator, and be on the lookout for disinfectant that could cause a skin rash on some workers whose skin is perhaps more sensitive. Check the supplier for their recommendations relative to cleaning agents, especially those for sensitive skin. Respirators must be stored in a convenient, clean, and sanitary place. Either the original container or a plastic bag is acceptable for storage. The respirator should not be stored in direct sunlight, dust, heat, extreme cold, excessive moisture, or damaging chemicals. Avoid storage in toolboxes or lockers unless the respirator is protected in a proper container. Respirators for emergencies must be stored in compartments constructed for that purpose. These compartments should be readily accessible with their locations clearly marked. The longevity of a mask depends on how much filtering capacity the respirator has and the amount of hazard in the air. Over time, a mask can get old and break down. Keep masks in a clean, dry place away from extreme heat or cold. Inspect it before and after use, according to the manufacturer's instructions. When considering respiratory protection, always ask yourself, what protection, as in which chemicals and particles, and at what levels, does the respirator provide? Is there more than one size? Which size should I use? How do I know if the gas mask or respirator will fit properly? What type of training do I need? Are there any special maintenance or storage conditions? Will I be able to talk while wearing the respirator? Does the hood restrict vision or head movement in any way? Can I carry the device in the trunk of my automobile? Is a training respirator available? When considering the purchase and use of respiratory protection equipment, it is important that one looks at all of the factors involved in the use of the equipment. A respirator is a device that is intended to protect employees from inhaling dangerous substances. As we've discussed, respirators are among the most important parts of protective equipment for working in hazardous environments. Choosing the right respirator requires an assessment of the workplace functions, processes, and environments that may create a respiratory hazard. Respirators work by either filtering particles from the air, chemically purifying the air, or supplying clean air from an outside source. There are different types of respirators available, like the self-contained breathing apparatus, SCBA, the air purifying respirator, and the powered respirator. The determination of which one is appropriate for the operation at hand must be based on the type of hazardous material being used or that is present on site that could pose a danger to life and health. Each respirator has different functions and has different types of filtering or purifying canisters or cartridges, or a combination of the two, that are designated to protect the wearer from specific hazards. Filters, cartridges, and canisters must not be used for any purpose other than what is specified by the category number and color coding. We must know if the worker is physically capable of wearing a respirator, so a medical evaluation must be done first. Then each respirator to be used must be fit tested based on the shape of the face to determine which respirator is best for that person. Then the wearer must be trained on the respirator he or she intends to wear. Finally, respirators must be cared for properly by cleaning with recommended solutions and stored in the proper locations per the manufacturer's directions. Did you know that slips, trips, and falls are leading causes of general industry accidents? In fact, these types of accidents constitute about 15% of all accidental deaths in the United States. That's more fatalities than all other causes combined, with the exception of motor vehicle accidents. The Occupational Safety and Health Administration, or OSHA, has developed standards for walking and working surfaces that can help prevent accidents. These standards provide safety requirements for general housekeeping, aisles and passageways, covers and guardrails, floor loading, floor openings and holes, wall openings, open-sided floors, walkways, platforms, and runways, stairways, ladders, and scaffolding. OSHA standards provide appropriate guides and safety precautions that can help keep workers safe. The standards for walking and working surfaces apply to permanent places of employment and exclude places that perform domestic, mining, or agricultural work. By the end of this course, you will be able to define terms such as floor opening, standard railing, standard toe board, floor hole, and wall opening. You will also be able to identify safety requirements to help prevent walking and working surface hazards related to general housekeeping, floors, walls, open-sided surfaces, stairways, ladders, and scaffolding. We will explore the safety requirements for housekeeping, aisles and passageways, covers and guardrails, and floor loading protection. OSHA's most frequently cited violations concern general housekeeping and walking and working surface standards. General housekeeping entails keeping workplaces clean, orderly, and sanitary. Every floor, workspace, and passageway must be kept free from protruding nails, splinters, holes, and loose boards. Drainage areas must be located near the area where wet processes will take place. Gratings, mats, or raised platforms must also be available. Workroom floors should be as clean and as dry as possible. Aisles and passageways must be able to accommodate large mechanical handling equipment. Permanent aisles and passageways need to be marked. Always watch out for obstructions. If you find an obstruction that could create a hazard, move it to clear the passageway. There are specific regulations pertaining to covers and guardrails. Anytime there is an open pit, tank, vat, or ditch, there is the potential for injury. To protect workers, covers and/or guardrails should be present. We will talk about covers and guardrails in more detail later in the course. The final piece of walking and working surfaces general requirements covers floor loading. The rule of thumb is that load ratings must be conspicuously posted if any type of floor loading is being conducted. Remember, these ratings were created to avoid accidents. You must never exceed the load rating limit posted. Next, we will look at some standards that help prevent injuries due to floor openings, floor holes, and wall openings. What exactly qualifies as a floor opening? A floor opening is any opening 12 inches or more in a floor, platform, pavement, or yard through which a person could potentially fall. We can break floor openings down further into two basic types: stairway and ladderway floor openings. Stairway floor openings must be guarded by a standard railing on all exposed sides, except the entrance. The purpose of the standard railing is to prevent individuals from falling into the opening. A standard railing consists of a top rail, mid-rail, and posts. The height from the upper surface of the top rail to the floor level should be 42 inches. The height from the mid-rail to the floor should be 21 inches. Ladderway floor openings exist for ladder access. In addition to guarding this type of opening with a standard railing, the passage itself must be either offset or guarded with a swinging gate. This will help prevent individuals from walking into the opening. A standard toe board must also be in place on all exposed sides, except the entrance. A standard toe board is a floor-level barrier that helps to prevent material from falling. The toe board must be at least 4 inches high, with no more than a quarter-inch clearance above the floor. We have discussed how to protect floor openings, which are, again, at least 12 inches on the shortest side. Next, we will talk about protecting floor holes. A floor hole is a smaller opening in a floor, platform, pavement, or yard through which materials may fall. It measures less than 12 inches, but more than 1 inch in its smallest dimension. Sometimes, floor holes are in the open and pose a risk that workers may accidentally walk into them. Floor holes must be protected either by a standard railing, a toe board, or by a cover. In cases where a cover or standard railing and toe board are not feasible, a human guard must be posted at all times to ensure workers are notified of the open hole and warned against the open hazard. One of these two options must be used to make the area safe. Sometimes, floor holes are blocked due to fixed machinery, equipment, or walls, and workers cannot accidentally walk into them. However, they still need to be protected. The best method of accomplishing this is by using a cover that leaves a 1-inch wide opening or less. Securing the cover prevents tools or materials from falling through. In addition to floor openings and holes, wall openings can also be hazardous. A wall opening is defined as an opening in a wall or partition that's at least 30 inches high and 18 inches wide, through which a person could fall. If there is a drop of more than 4 feet, these types of openings must be guarded by a rail, roller, picket fence, half door, or equivalent barrier. The person working below this hole may be exposed to falling materials. In this case, a removable toe board or equivalent is required. Imagine you are working at a building construction site. On the ground floor, you notice there is a hole with a ladder that leads to the basement level. Which of the following must be in place to protect workers on the site from injury? Is it A, standard railing, B, standard railing with a swinging gate, C, standard toe board and cover, or D, offset entrance with a standard railing and toe board? The correct answer is D, offset entrance with a standard railing and toe board. For ladderway floor openings, a standard railing and toe board must be in place on all sides except the entrance. The railing prevents anyone from falling into the opening, and the toe board helps keep tools or other materials from falling down the opening and injuring someone below. Additionally, the entrance to the ladder must be offset or have a swinging gate. This will prevent individuals from walking into the opening. OSHA standards for walking and working surfaces include ways to safeguard against accidents due to open-sided surfaces and stairways. We will start with open-sided floors and platforms. The rule of thumb is anytime there is an open-sided floor or platform 4 feet or more above the adjacent floor or ground level, a standard railing on all open sides must guard it. The only exception to this rule is when there is a ramp entrance, stairway, or fixed ladder. Sometimes a toe board must also be in place. This is true if a person can pass below the open side of the floor or platform, if there is a moving machinery below the open side, or if falling materials could become a hazard. Regardless of their height, open-sided floors, walkways, platforms, or runways above or adjacent to dangerous equipment, pickling or galvanizing tanks, decreasing units, or similar hazards require a standard railing and toe board. Next, we will discuss stairways. We start with the basics. What is a stairway? Stairs are a series of steps leading to a floor or piece of equipment. A riser is the vertical part of a step. When there are flights of stairs with 4 or more risers, there must be a standard stair railing or handrails. In some instances, fixed industrial stairs are in place. Fixed industrial stairs are required for access to and from places of work where operations require regular travel between levels. This applies to interior and exterior stairs around machinery, tanks, and other equipment, and stairs leading to or from floors, platforms, or pits. In addition to meeting standard stair railing and handrail requirements, fixed industrial stairways must meet an extra set of requirements. First, treads must be slip-resistant with uniform rise height and tread width. Secondly, stairs must be able to hold 5 times the expected load with a minimum load resistance of 1,000 pounds. Finally, they must be at least 22 inches wide. Portable ladders are useful for workers to access areas in which stairways or fixed ladders are not in place. Today, we will look at all 3 types of portable ladders: step ladders, single rung ladders, and 2-section rung ladders. Step ladders cannot exceed 20 feet in length. Step ladders must also be equipped with a metal spreader or locking device to securely hold the front and back sections in an open position. Single rung ladders max out at 30 feet in length, and 2-section rung ladders run a maximum of 60 feet long. If your ladders are short, never splice them together to make one longer ladder. Portable ladders must be inspected frequently, kept in good condition at all times, and be free of sharp edges, splinters, oil, grease, or other defects that could potentially affect their use. If a ladder is found to be defective, withdraw it from service and mark it dangerous. Do not use. Furthermore, what is the correct way to use a portable ladder? If you are using a metal ladder, make sure that it is not near electrical equipment. Do not plan to use a ladder in a horizontal position to act as a scaffold or work platform. Instead, place a ladder on a secure footing and lock it in place. Portable rung and cleat ladders should be used at an angle where the horizontal distance from the top support to the foot is 1/4 the working length of the ladder, or the length along the ladder between the foot and top support. If you are accessing a roof, be sure that the ladder extends at least 3 feet above the point of support. Once your ladder is secure and you are ready to climb or descend it, always be sure to face the ladder. If you are using a step ladder, never use the very top part, called a platform, as a step. Another type of ladder is a fixed ladder. Fixed ladders are permanently attached to a structure, building, or piece of equipment. All fixed ladders must be regularly inspected and maintained to be in safe working condition. Fixed ladders should have a horizontal pitch in the range of 75 to 90 degrees. If the ladder is longer than 20 feet, a cage or well is required to have a maximum unbroken length of 30 feet. However, ladder safety devices may be used instead of cage protection for tower, water tank, and chimney ladders that are more than 20 feet in unbroken length. Ladders used in construction have a different set of standards, so check with your supervisor or safety professional in those situations. Now, we will switch gears and discuss scaffolding. Scaffolding is a temporary platform designed for workers to reach areas above the ground or floor. There are several safety requirements to adhere to when using a scaffold. Scaffold structures must meet specific requirements. The scaffold must be capable of supporting 4 times the maximum intended load. Damaged or weakened scaffolds must not be used. Before you begin any work using a scaffold, consider the environment. Is it raining? Are there high winds, snow, or ice? If so, do not work on a scaffold. Next, assess whether there are overhead hazards that workers will need protection from. This is very important. Always be aware of overhead hazards, such as power lines when working on scaffolds. Make sure that there is access to the working platform level by ladder or ramp. Do not alter or move the scaffold while it is in use. If the platform is higher than 10 feet, use guardrails, mid-rails, and toe boards. If workers need to walk beneath the scaffold, use wire mesh between the toe board and the guardrail. A scaffold is going to have a load of 200 pounds at a distance of 40 feet above the ground. The scaffold is capable of supporting 600 pounds and is equipped with guardrails, mid-rails, and toe boards. No one will be working or passing beneath the scaffold. Is it acceptable to use the scaffold in this situation? Is the answer A? The scaffold is acceptable to use as is. B. The scaffold needs to be able to support 800 pounds. C. Scaffolds should not be used at distances higher than 30 feet, or D. Wire mesh should be used between the toe board and guardrail. The correct answer is B. The scaffold needs to be able to support 800 pounds. Scaffolds must be capable of supporting 4 times the maximum intended load. 4 times the 200-pound load would mean the scaffold must hold at least 800 pounds. Scaffolds can be used at distances higher than 30 feet. However, wire mesh must be used between the toe board and guardrail if workers will pass beneath the scaffold. In this walking and working surfaces course, we discuss the safety requirements for general housekeeping, aisles and passageways, covers and guardrails, and floor loading protection. We identified requirements that help protect workers from injury due to floor openings, floor holes, and wall openings, and ways to work safely around open-sided surfaces and stairways. We discussed both portable and fixed ladders and the correct way to use them. Finally, we identified the requirements for scaffolds and the environments in which they are safely used. In addition to being safe and cautious in the workplace, following OSHA requirements can help avoid workplace accidents that occur due to walking and working surfaces.